Welcome back, electric enthusiasts, to another episode of Electricity Frenzy. In this episode, we will be discussing an issue that puzzles many people, the tripping circuit breaker. Although it may seem like a buzzkill at times, remember that the quirks of our electrical system are often safeguards in disguise. So, let's demystify the tripping breakers and help you become a savvy breaker whisperer. Safety first, a non-negotiable principle. Electricity is a formidable force, demanding respect and caution. Before we embark on our troubleshooting quest, never venture into breaker box territory if you're feeling uncertain or inexperienced. A professional electrician is your go-to ally. Always switch off the main power supply before attempting any fixes with individual breakers. Envision it as hitting the pause button on your home's electrical narrative. Deciphering the enigma, why do breakers trip? Understanding the motives behind a breaker's discontent is crucial. Here are the 4 primary instigators: circuit overload, short circuit, faulty appliance, and bad breaker. Let's break it down. 1. Circuit overload. Visualize your breaker as the diligent traffic warden of electricity. Each circuit is designed to handle a maximum electrical load, amps. Overloading a circuit by connecting too many devices forces the breaker to intervene, halting the flow to prevent overload. Certainly. Let's break down the explanation of circuit overload in more detail. Circuit overload explained. Imagine your home's electrical system as a network of highways, with each circuit acting as a specific road designed to accommodate a certain amount of traffic, represented by electrical current measured in amps. Now, picture the circuit breaker as a vigilant traffic warden stationed at the entrance of each road. Every device you plug into an outlet or connect to a circuit draws a certain amount of electrical current to function. This current flows through the wiring of the circuit, much like vehicles traveling along a road. However, just like a road can only handle a limited number of vehicles at a time before congestion occurs, each circuit has a maximum electrical load it can safely carry. When you connect too many devices or appliances to a single circuit, you're essentially sending more traffic down that electrical road than it can handle. This excess current puts a strain on the circuit's wiring, increasing the risk of overheating and potentially causing damage or even a fire. To prevent this dangerous situation, the circuit breaker acts as a safety mechanism. It constantly monitors the flow of electrical current through the circuit. If it detects that the current has exceeded the safe limit for an extended period, usually due to overload, it trips or shuts off power to the circuit, much like our diligent traffic warden stopping traffic to prevent gridlock. By interrupting the flow of electricity, the breaker protects the circuit from damage and reduces the risk of electrical hazards. It's a crucial safety feature designed to safeguard both your home and its occupants from the dangers of overloaded circuits. In essence, circuit overload occurs when you demand more electrical power from a circuit than it's designed to handle, triggering the breaker to step in and prevent potential harm. This analogy helps illustrate the importance of respecting the limitations of your electrical system and avoiding overloading circuits to ensure safe and reliable operation. 2. Short circuit. This scenario is akin to an unexpected shortcut in your electrical system, where wires unexpectedly cross paths. It's abrupt, unintended, and prompts an immediate response from your breaker. Short circuit demystified. Imagine your home's electrical wiring as a meticulously planned network of roads, each wire serving as a path for electricity to travel from one point to another. Now, envision a scenario where 2 wires that are not supposed to come into contact suddenly intersect, creating a direct, unintended path for electrical current to flow. This phenomenon is what we refer to as a short circuit. In simpler terms, a short circuit occurs when the hot wire, carrying current, and the neutral wire, completing the circuit, make direct contact with each other, bypassing the normal route through devices or appliances. This shortcut drastically reduces the resistance in the circuit, allowing an excessive amount of current to flow uncontrollably. Just like a detour on a road that leads to unexpected chaos, a short circuit in your electrical system disrupts the normal flow of electricity, causing a surge of current that can pose serious risks. The sudden increase in current generates intense heat, which can quickly escalate, potentially causing wires to melt, insulation to ignite, or even triggering a fire. In response to this hazardous situation, the circuit breaker swiftly intervenes. It senses the abnormal surge in current caused by the short circuit and immediately trips, cutting off power to the affected circuit. This rapid action helps prevent further damage to the wiring and mitigates the risk of electrical hazards. A short circuit is an abrupt and unintended event that demands immediate attention. It's like a red flag waving in your electrical system, signaling a potential danger that requires prompt resolution. By understanding this analogy, you can grasp the urgency and importance of addressing short circuits swiftly and effectively to maintain the safety and integrity of your home's electrical infrastructure. 3. Faulty breaker. Age and wear can compromise a breaker's efficiency, leading to premature trips. It's the equipment's way of crying for attention and possibly retirement. 4. Faulty appliance. Occasionally, the troublemaker is an appliance drawing more power than it should, due to internal damage or defects. This can prompt the breaker to trip in defense of your electrical system. Navigating the troubleshooting maze. Detective work required. Pinpointing the problem requires observation. A breaker that trips often under normal load suggests an overload issue. Immediate tripping post-reset hints at a short circuit. Addressing overloads and short circuits. Overload issue. As I just told you, an overload occurs when too many electrical devices are drawing power from the same circuit simultaneously, exceeding its capacity. To address an overload issue, identify the appliances or devices that are connected to the circuit that keeps tripping. Unplug appliances and try redistributing the load by unplugging some devices from that circuit and spreading them out over different circuits. Switch on the tripped breaker, it should not trip again. Consider upgrading the circuit to handle a higher load, if necessary, by consulting with a qualified electrician. Avoid using high-power appliances like space heaters or air conditioners on the same circuit as other heavy loads. 1. Short circuit. A short circuit happens when a hot wire touches either a neutral wire or a ground wire, causing a sudden surge of current and an instant tripping of the breaker. This is different from an overload, as in a short circuit, if you try to turn on the breaker, it will trip immediately and may produce a spark inside it. To address a short circuit issue, inspect the outlets, switches, and any exposed wiring for signs of damage or exposed wires. If you find any damaged wiring or connections, replace or repair them as necessary. The cause of the short circuit may be in an appliance, which I will discuss later in this video. If you cannot locate the source of the short circuit or if it persists after repairs, consider consulting with a qualified electrician to diagnose and resolve the issue safely. Faulty appliance. If a circuit breaker trips when turning on an appliance, it may be due to a short circuit inside the appliance indicating a fault. To determine if a malfunctioning appliance is causing electrical instability, disconnect it and reset the breaker. If the stability is restored, the appliance is likely the issue. In this case, it is recommended to refer to the manufacturer's guidelines or consult with a repair technician for further steps. It is not advisable to attempt DIY repairs on major appliances. Faulty breaker. A specialist should handle electrical breaker issues. If a breaker trips unexpectedly, it could be due to a faulty appliance or breaker. Replacing or repairing a breaker is a risky task that requires professional tools and knowledge. Pro tip: maintain a detailed log of your circuits and the appliances they power. Monitor for any anomalies or performance issues. This proactive approach can be invaluable for troubleshooting and future reference. A parting reminder: while the allure of DIY electrical work can be strong, prioritizing safety is paramount. Uncertain situations call for the expertise of a licensed electrician, the true circuit whisperers who ensure our homes remain safe and powered. Stay enlightened, stay inquisitive, and let the current flow safely. P.S. Craving more electrifying insights? Drop your questions in the comments, and your topic might just spark our next electricity frenzy adventure.